Using the for loop, we are now going to take a look at a program, how we go about generating the Fibonacci sequence. So let us first take a look at the Fibonacci sequence, which has already been discussed in programming constructs before. So here, this 0 and 1 are the only two digits which start the Fibonacci sequence. Let's call 0 as the first, second, the 1 as the second. Now if you look at this one, it is the sum of the previous two digits. 0 plus 1 is 1. 2 is the sum of the previous two digits. It is 2 here, 1 plus 1. 3 is the sum of the previous two digits, 2 plus 1. 5 is the sum of the previous two digits, 3 and 2. 8 is the sum of the previous two digits, 5 and 3. So this way the sequence keeps going on, and the user is going to give you a value of limit or n, and you're going to generate Fibonacci sequence up to that particular point. So I'm going to give the first name of the first variable as 0. This is first, this is second as 1, and this fellow current was also 1. Now I'm going to ask the user, so if you see the variable declaration, first is 0, second is 1, current is 1, and this limit represents the last Fibonacci number you are interested. Count is a variable used to keep track of how many Fibonacci numbers you have printed. So I'm asking enter the Fibonacci limit. Let us say I enter the value of limit as 21. Okay. So limit is 21. First what I am doing is I am printing the value of first and second. So I am printing 0, 1. And then I go into the for loop where the major or the complete logic actually can be seen very clearly. So what am I trying to do in this for loop? Current. As long as this particular fellow is less than or equal to 21, I am going to keep generating the sequence and keep printing the sequence. This variable count is going to keep track of how many Fibonacci numbers I have printed. Since I have already printed 0 and 1, I have made count equal to 2. So this condition is true because 1 is less than or equal to 21. Then what am I doing next is I am coming here in and I am printing the value of current. Now after I print current, what should happen is first should take the value of second and second should take the value of current. So this becomes 1, this becomes 1. So see what happens. First takes the value of second, second takes the value of current, and the new value of current is 1 plus 1, which happens to be 2, which is the sequence. Now we go back here. Before we go back here, we're increasing the value of count by 1. Count has now become 3 because we have printed 3 terms. Now current 2 is less than or equal to 21 is true. So I am coming here and I am printing the value of current, which is 2. Then again this exchange takes place, first to second, second to first. This becomes 1, this becomes 2 as per this logic, and this becomes 2 plus 1, which becomes 3. Now again I increase the value of count by 1. Count ends up becoming 4. Here I am keeping track of count is 4. Now is 3 less than or equal to 21? It is true. So I am coming in here printing 3. Then I am doing this exchange process again. This is 2, this is 3, and now current becomes 5. Now I am coming here, count becomes 5 because if you see I have printed 5 digits. Now current is 5. 5 is less than or equal to 21 is true. So I am coming and printing current here, which is 5. After I print 5, then this exchange takes place. This becomes 3, this becomes 5, and this becomes 5 plus 3, it becomes 8. Now again I increase the value of count by 1. It becomes 6 because I have printed 6 digits. Current is less than or equal to limit. So what is current? Current is 8. 8 is less than or equal to 21. So I keep repeating this process. Okay. So let's continue. So 8 is less than or equal to 21. So I come here and I print 8. Now what happens to first becomes 5. This fellow becomes 8. 8 plus 5. Now current becomes 13. count ends up becoming 7. 13 is less than or equal to 21, true. Count has become 7, that's fine. Now I print the value of this fellow, which happens to be 13. So I print 13. Now first becomes 8, second becomes 13. 13 and 8 is current becomes 21. 21 is still equal to 21. Count ends up becoming 8. So I come here and I print 21. First becomes second. That is, first takes the value of, what was the last value of this thing? Okay, first takes the value 13 and next second takes the value 21. So 21 plus 31 is 34. So the new value of current happens to be 34. Now 34 is not less than or equal to 21. It doesn't go here. It increases the count and it fails. Once I come here, I am going to print total number of terms. It's going to print how many terms we have printed. 1, 2, 3, 4, 5, 6, 7, 8, 9. Count had also become 9 if you had noticed clearly, because I printed 21 and after 21 I increased this to, from 8 I made it 9, and after I made it 9 current had become 34. The condition failed and I came here. Total number of terms is going to print as 9 and these are the terms. So this was a simple problem to show you how the Fibonacci sequence is generated. Make an effort to understand such logic, because if you can understand this logic, there's no program which is going to be really challenging for you.